Let's talk about one more crucial concept of a networking, which is subnetting and supernetting. Whether you are working on a cloud, which includes AWS, Azure, GCP, or even on-premise data center, these concepts of subnetting and supernetting are really important to effectively manage your network, but also protect your network from external threats. Let's start with our first concept of a subnet or subnetting. And you might be wondering that why I am showing you the floor plan of an house. So I'm just trying to take an example over here. So here in this particular diagram, you will see a floor plan of a particular home. So consider this home as a large network, and these bedrooms like a bedroom 1, 2 and 3 are considered to be the sub network present within that large network. Let's draw some boundaries over here so that we can differentiate our sub network from our large home network. So here I'm just going to draw some boundaries. So this is like a subnet of my bedroom 2. This is my subnet of my bedroom 1, and this is my subnet of my bedroom 3. And also keep the things simple. I'm just putting the names like subnet 1, 2 and 3 based on bedroom 1, 2 and 3. And along with that, here I'm just drawing the this yellow color rectangle, which is my home network, which is my large network, and I'm calling this as my home network. All right, so now we have created our large network and we have created our 3 sub network, which we call it as a subnets. Now the question comes like, how will you create or assign the IP addresses to these? One is our large network, which is our home network, and the 3 smaller subnets. So here is the thing. So first of all, we need to assign the CIDR range for my home network. So here you can see this is my home network and I'm assigning a CIDR range with /23, and that will give me around 512 IP addresses. So this is my large network in which I can have 512 IP addresses. And if you don't know like how the CIDR ranges work, then I have already uploaded a CIDR range tutorial onto this particular series, so please go and check that particular tutorial, which will make you more knowledgeable on how to work with the CIDRs. But in a nutshell or in a short, that this CIDR range depends upon the number which you are putting at the end of this IP range. So if the number is higher, then you will get little lesser IPs. If the number is lower, then you will get a little bit more IP addresses. So here it is ending with 23 and you will get 512 IP addresses. Also, there are some online CIDR calculators, so which you can see over here onto the screen. So here you need to enter the IP address and then you need to check the ranges of our CIDR, how many IPs you can get. So here you can see if you are ending with 23, then you can get around 512 IP addresses, which you can see over here. And similarly, if you wanna like increase the number, let's say 24, then click on calculate, then you can see here you will be getting 256 IP addresses, and these are the ranges of your IP addresses. So similarly, you can just go over here and then you can just do the calculation based on your CIDR ranges and how many IP addresses you need. So that's a quick cheat code if you really want to calculate how many IPs are available within your CIDR range. Now you know that we have a 512 IP address in which is available onto our large network, which is our home network. And now we need to divide this 512 IP address within our subnet 2, 1 and 3. I mean in the 3 subnets. So how we can do that? So for that, what we need to do over here, we just need to create a few more CIDR ranges for our subnet as well. So here you can see in our subnet 1, I am ending with /25, and as I already told you, if the number is higher, then you will get a little lesser IP addresses. So here you can see it is ending with 25 and you will get 128 IP addresses, which you can verify from our calculator as well. So here if you go over here and click on 25 and then click on calculate, then you are getting 128 IP addresses. Similarly, on subnet 2, I am just gonna assign the /25 and here I will also get a 128 IP addresses. But the range are changing. So here you can see the IP address range is 11.0.0.0/25, but here in subnet 2, I will be getting 11.0.0/25. .128/25. So my first IP address will start from 11.0.0.128 and my second IP address will be 129 at the end of this particular IP address, and subsequently I can add +1 until I get or till I reach to the 128 IP addresses, and which you can see from our calculator over here also. So if I put 128 and then click on calculate, so here you can see 128, but the IP ranges are from here till here. So it will like start with 128, it will end it on 255. Okay, so now out of 512, we have consumed around 256 IP addresses. So out of which 128 in the subnet 1 and 128 in the subnet 2. Now we are left with 256 IP addresses. So either what you can do, you can consume all of the 256 IP addresses in subnet 3, or you can even save some of the IP addresses from that 256 pool. So just to keep the thing simple, I'm just going to consume all of the remaining 256 into subnet 3. So here I'm just going to create a CIDR range with /24. So now with /24, I will be getting 256 IP addresses. So in total, in our large network, which is our home network, I had a 512 IP addresses, and now I have consumed all of the 512 IP addresses within my 3 subnet. So this is how we divide our IP ranges based on the subnet, and we try to assign a smaller ranges in our subnet so that we can have or we can consume the larger IP address pool which we got from this home network. Alright, so now you're familiar with the subnetting and how we are dividing the IP addresses. Now let's put that concept into the actual practice and how we are going to define or create our own VPC, and VPC we call it as our large network. So here you can see this is my VPC and this is our large network which contains our subnet, which is 3 subnet which I have created. And here we are having a 1 public subnet which you can see, and here we are having 2 private subnets. It's up to you like how many public and how many private subnet you wanna create. So I'm just taking a very simple example to create a 1 public subnet and create a 2 private subnet. Alright, so again I'm taking the same IP ranges over here. So here I'm ending with 23, the CIDR range, and I will get a 512 IP address. And similarly I'm just dividing those IP addresses into my subnet. So 2 of them are ending with 128, so here it will sum up to 256, and remaining 256 I'm just going to consume in my 3rd subnet. But you might be wondering that you already shown the previous diagram and what's the difference between these and that. So previous diagram which I have shown, where I have shown the home network, so that was just for explaining the concept, but in reality this is how you are just gonna create your VPC and subnet. And the key thing over here is that don't worry, I'm just going to show you one example on AWS cloud that how this VPC and subnets are present. But in reality, this is how the things will look like when you are going to work on any cloud environment or any private data center or on-premise data center. So you will always see the CIDR ranges, you will always see the smaller CIDR ranges, and you will always ask this kind of a question, which is the VPC, which is the subnet, is it a public subnet, is it a private subnet? Don't worry, I'm just going to explain what is public subnet and private subnet. But these sort of question you are going to face and you are going to ask when you are working with the networking. Let me show you one of the real-time example on how to play with VPC and subnet on one cloud provider. So here I'm going to take one example of a AWS, but these concept of a VPC and subnet are also applicable on any other cloud provider or even onto on-premise data center. But there is a slight change over there, but overall the core principle still remains the same. So let's take a look how we can create the VPC first of all. So here just type the VPC, click on the VPC over here, click on create VPC, and here you can see the options. So first let's create and keep the thing simple. I'm just going to create VPC only. So here I'm just going to put like a test VPC. And here I'm just going to define the IP range, and I'm just going to take the same example. And here I'm just going to end with 23 so that I will get around 512 IP addresses. Okay, so here I have defined the IP range, and after that I'll just keep the thing simple. I'm just going to simply click on create VPC over here. And here you can see our test VPC has been created, and here this is the CIDR range which is we have assigned to our VPC. Now let's create the subnet. So here we have an option in AWS for creating a subnet. So on the left hand side you can click on subnet, click on create subnet over here, and then you need to select the VPC. So here if I show you onto the diagram, so here you can see this is this VPC we have created. So first of all we need to first select the VPC which we have created, and inside that VPC we are going to create these subnets. So let's go back and here select the VPC. So it is our test VPC, and here we are going to create the subnet. So here we can say like a subnet 1, and I can put like a test so that I can identify it is a test subnet. So test subnet 1 availability zone. So yeah, availability zone is a concept in AWS, but you can put your subnet into the different data centers. So here I'm putting into the Frankfurt, so that if one data center goes down, still we have other data center to serve our request. So that's a basic thing behind it. And here I'm just gonna put like this is the CIDR range of our VPC, but here I'm just gonna define the CIDR range for my subnet. So I'm just gonna put 11.0.0.0/23, and here not 23, it should be 24. So here you can see it is assigning 256 IP addresses for my subnet 1. Again, you can click on add one more subnet, and let's check the IP ranges once again. So we have already assigned 24. This we have already assigned. So let's assign 25 to other subnet. So here I'm just gonna click on like a test subnet 2, and here I'm just gonna assign 11.0.0 and .128 and slash, and then I can assign it's 25 over here. So here you can see 128 IP addresses, and similarly add one more, and then we can assign one more IP address by the first assign the name test subnet 3, and here I can assign the 11.0.0 and probably 256 I can assign it, and then after that 25. So once you assign, I think it's 256. So this is how you are just gonna create the VPC, and then you are gonna create the subnet. So this is just an example. I just wanted to show to you that how in reality it works. All right, so now we have talked and we have seen like how to create a VPC and subnet. So let's talk about the subnet a bit more, like a private subnet and public subnet, and what is the difference between those subnet. So here you can see there is one public subnet which is over here, and here these are our private subnet which are present over here. So the difference between the public and private subnet is that any public service which are present or which we want to host will always reside inside our public subnet. So here you can see these are the API which we call it as a public API, which will be available from us. Then we are going to put into our public subnet, because this public subnet will have access to internet, or any person sitting in outside of the world like here outside of our VPC should be able to access these particular services. So that's why we put those services into our public subnet, which can be your mobile app, which could be your web application, or which could be your public APIs which you are exposing. But apart from those, like which are not meant to be public, are kept in our private subnet, which can be over here. And what are the good example of our services which are present into private subnet is like a database. So of course, if you are having an application or API which is available onto the public subnet, then they are going to store some data into our database. So this database is not supposed to be public, because this database is only going to be used by this API application for storing and fetching the data. So that's why this particular like a database we are going to keep inside our private subnet. So we have one more private subnet. So here you can keep another database inside that particular private subnet. So that's the basic difference of creating a public and private subnet within our VPC. Here is an example of the routing which you are going to create within your subnet. So this is just an hypothetical example, but here I'm just trying to explain you the concept. So we need to create the route tables within your network for your subnet so that you can route the request for your subnet based on those route table. So what the route table will contain, so it will contain source and destination. So here you can see the public subnet. So here I'm just assigning the public IP address, which is a bit different. So this is just a dummy public IP I'm just trying to show you. That's why I have just taken the range. And here it is showing you the destination, which is the IP range present within your subnet, or which is your public subnet. So this is the route table for your public subnet because it contains public address, which is your like a source, and the destination is going to be your IP address within your subnet. And then here I'm showing you the route table for your private subnet, which contains source from your like can be your public subnet or other private subnet, and destination is like your current private subnet. So this is how you define the routing within your network where you have a different type of subnet. All right, so now we have talked really quite a lot on subnetting and how to divide our network into smaller subnet. Let's talk about the supernetting, and the concept I'm talking about is collecting and aggregating all the smaller network and creating one single unit of a network. That is called supernetting. So supernetting is just an opposite of our subnetting. In subnetting, we create a smaller subnet, but in supernetting, we just aggregate or add all of those and create a one single network, which is we call it as a supernetting. Then you might be wondering that why do we need a supernetting when we are creating the subnetting for more granular accesses? So of course, supernetting is really important when you have a very large network. For example, like your company is offering the services across the world. So of course, you can create a subnet based on the cities, but if we talk about managing that large network, then you need to put a supernetting based on the country. For example, India have a lots of states, so those lots of states can be called as a subnet network, but in supernetting we will call India as a one supernet for those subnet. So that's the advantage of supernetting, so that you have a more control on a larger region. So similarly, another supernetting example could be that in Europe we have a lots of countries. So those lots of countries you can consider as a subnets, and then we can create one Europe as a supernet so that we can control some of the rules or routing rules based on the country. So that's how the supernetting like really helps you to aggregate and create a one single logical unit of a network so that you can put some more like a larger rule onto your network. So that's where the supernetting comes in handy and really helpful for you. And unlike the subnetting, we have a various route table, but in supernetting, we will have a single route table to manage our all routes for our source to destination. Like previously, we have seen the 3 route table, but here we will have a single route table to manage the routing for your whole network. So of course, behind the scene, you can have a subnet, but in supernet, you will have a one single table to manage all of your network or routes, which are like on a higher level. So that's the basic difference when it comes to subnet routing and when it's come to supernet routing. I hope you are liking these kind of videos and series. Then please considering subscribing to this channel, because that means a lot and that keeps me motivated to create these kind of content. And also, if you are interested into more deep dive content, then I have a membership program on my YouTube channel where I keep on publishing more in-depth session on this cloud DevOps and various tools like Terraform, Ansible, and Jenkins. So if you really like those kind of a content, then you can consider subscribing to this membership program where you will get these kind of a content, and as well as access to the Discord channel where you can just ask question directly to me. So let's get back to the topic once again. So we have pretty much covered the supernetting as well as subnetting. The only thing which I would like to put at the end is that how you will plan the supernetting and subnetting. So keep in mind that always plan ahead. Always try to keep a CIDR range with the thought that you will never run out of those CIDR ranges in future. Otherwise, it will be a lot of trouble for you to like increase the IP ranges in your VPC or in your subnet. So be mindful about that. CIDR ranges are very limited. If you go with the smaller CIDR range, then you will again end up like, hey, I'm running out of my IP range in my subnet or VPC. So then you need to like make a changes over there. And also just be mindful about the IP changes so that you are not overlapping with other subnet IP ranges. Otherwise, there will be a lot of confusion and trouble for you, so that if you have overlapping IP addresses, and that will lead to the similar IP in the subnets, and that will create a more confusion for troubleshooting. So those are the few tips which you can keep in mind when you are working with the supernetting and subnetting.